In chapter 12, we're going to look at the log function, and you're probably not surprised. Part of the chapter is going to address the calculus of log. You're going to find something quite interesting in that we can differentiate a log function. However, you will never be asked to integrate log x. So, we will see what we can integrate as a result of looking at the derivative of the log function. And it turns out to be something that we previously haven't been able to differentiate and may not be something that you were terribly aware of. However, it's really important that in this chapter you make the connection between the derivative of the log function, what it turns into, and then the integral of that particular function. More on that later. Obviously, we're going to do a bit of revision of logs, and you'll find that this chapter is followed by the exponential chapter, and just a little bit of interesting, I suppose, fact, that we say that the exponential function and the log function are inverse functions. One undoes the other, and you probably know that from the definition of a log. The log of a number to a given base gives the power. So if we've got the power written in a function, we've got an exponential function. However, if we take the log here, then we're getting the power. So, there's a clear connection between the two. Not that it is demonstrated in the calculus of either of them. There's no connection between the two functions. However, if we graph them, you can see that they are the inverse of one another, because graphically the inverse is demonstrated by showing the relationship through the line y equals x. And you can see that if we were to fold along the line y equals x, then we would get the other function. And that's one way to demonstrate that functions are the inverse of one another. It's really important that you know the definition of a log. And the log of x to base a, if that is y, then we know we've taken the log of some number x, so here's sitting x. The base is a, and the y must be the power. A little example, we know that if we take the log of x to base 2, then we're talking about some number. X has y as its power, and its inverse. Its inverse. Remember, inverse is also demonstrated algebraically by swapping the positions of the x and the y. 12a is going to focus more on the rules or laws for logs, which we have looked at before. So you're just going to get a bit of practice on that. The change of base rule, don't forget that one. Okay, let's have a look at some of these. Okay, in this first one, you'll notice that I've actually introduced a bracket there. The notation's not very clear when I typed it up. What I actually mean is show that the log to this unusual base, a to the power x, that is the entire base of b, can be written in this format. And they're giving you a bit of a hint in that you'll use the change of base rule. So in all show questions, let's take the left-hand side, which is log, and I've tried to show it a bit more obviously here in my handwriting of the left-hand side. And since that is our base, we're just going to write this using the change of base rule. So we know that that would be log of b, and I've deliberately not put the base in yet, on log of a to the x. Now, like I said, I've deliberately not put the base in. We need to think about the best base to choose, because that is a choice that we can make when we use the change of base rule. We can actually rewrite this to any base. Do I want it to base 10? Thinking about here, probably not. If do I want it to base b or x? What do I want it to? Hopefully you can see, and again, by focusing on where we're heading, which we always should do in a show or a prove, then we can see that they're talking about log of b to base a. Let's introduce that now. So, because we've got the flexibility to do that, choose our base. Let's choose base a. Probably based mostly on where we're heading. With that in mind, we've got log of b, which I'm really happy about, to base a, because that's what I can see I need in the end. What's log of a to the x to base a, or log to base a of a to the x? Using that index rule, it's x times log to base a of a, but we know that log to base a of a is 1. What do I raise a to get a? It's 1. So that becomes x times 1, and we've got log to base a of b just on x times 1, which is x, which is equal to the right-hand side. This is not a common association, that log to base a to the x of b is equal to log to base a of b all over x. And it's not something that we learn, it's not part of the rules. However, in this question, because it says hence, then to evaluate this, especially without using a calculator, we will use that rule. So, for example, if we had log of b, log of some number, to say 2 cubed, that's the same as log to base b of a, which in this case is 2, over x, which was the power. Nice little pattern. So we're going to use that sort of thing to evaluate this question. Now you can see that the base isn't written in power form, which we need it to be for us to use this little rule. So hopefully 27 is fairly familiar to you, and it's 3 to the power 3 of 81. So now the pattern is that it is log to base, that works nicely because it's 3 to the power 3, log of to base 3 of 81 all over 3. What do I raise 3 to get 81? Well, that then is a 4, and 4 on 3 is 4 on 3. So I might have gone through that a bit too quickly for you. So rewind, slow it down, whatever you need to do to get that. And don't worry too much about, well, you've never seen this before. That's fine. It's not a rule that is part of our syllabus. However, it is just something that could come up in a question, and you we'll use it as directed. Okay, you should be right then to do exercise 12A.